Hey there, science fans! Today we're diving into the amazing world of ants. These little creatures might seem insignificant at first glance, but don't let their size fool you. Ants are master builders, brilliant navigators, and teamwork champions. For years, scientists and engineers have been looking to ants for inspiration. How can we learn from their incredible abilities? How can we use their natural genius to create new technologies? Get ready to be amazed because the world of ants is full of surprises. Ants have been around for over 100 million years. That's older than the dinosaurs. They've had plenty of time to evolve and perfect their skills. We're just starting to unlock the secrets of their success. And what we're finding is truly remarkable. It turns out that these tiny creatures have a lot to teach us about efficiency, teamwork, and problem solving. So, put on your thinking caps and let's explore the fascinating world of ant-inspired innovation. Have you ever seen an anthill in action? It's a sight to behold. Thousands of ants, each with their own job, working together seamlessly. It's like a well-oiled machine, but instead of gears and cogs, it's all about communication and cooperation. Ants are masters of efficiency. They've evolved to work together in a highly organized way, ensuring the survival of the colony. Each ant plays a specific role, whether it's foraging for food, caring for the young, or defending the nest. This division of labor is key to their success. Just like a well-coordinated team, each ant contributes to the bigger picture. And because they communicate so effectively, they can adapt to changing circumstances in a snap. Imagine a team of engineers working with that kind of synchronization and efficiency. That's the power of ant teamwork. It's a symphony of cooperation, and it's a huge inspiration for scientists and engineers looking to design more efficient systems. Now let's talk about swarm intelligence. It's a fancy way of saying that ants are smarter together than they are alone. When you observe a single ant, it might seem insignificant, just wandering around aimlessly. But when you look at the entire colony, you see a different picture. Think about it. A single ant might not be a genius, but as a group, they can solve complex problems and make incredibly sophisticated decisions. They can build bridges with their bodies, carry food that is many times their weight, and even defend their colony from threats. How do they do it? It's all about communication. Ants have developed an intricate system of interaction that allows them to work together seamlessly. Ants communicate primarily through chemicals called pheromones. These pheromones are like messages that ants leave behind for others to follow. They leave trails of these pheromones to signal to other ants where to find food, avoid danger, or even the best route to take. This chemical communication is incredibly efficient and allows the colony to function as a single, cohesive unit. Imagine navigating a dense forest. Alone, it would be challenging, but with a well-marked trail, it becomes much easier. That's what pheromones do for ants. This constant communication creates a kind of collective intelligence, a hive mind, if you will, that allows the colony to adapt and thrive. Pretty cool, right? This hive mind is what makes ants so successful in their environments. This concept of swarm intelligence has enormous potential in robotics. Scientists and engineers are taking inspiration from ants to develop new technologies. Imagine a swarm of tiny robots, each following simple rules and communicating with each other, working together to accomplish a larger task. These robots can be programmed to mimic the behavior of ants, allowing them to perform complex tasks efficiently. That's the power of swarm intelligence in action. By working together, these robots can achieve things that would be impossible for a single robot to do alone. From search and rescue missions to environmental monitoring, the possibilities are endless. Swarm intelligence could revolutionize the way we approach problems, making tasks that once seemed insurmountable, achievable. Section 4. Nature's skyscrapers building design inspired by ant architecture. Let's move on to architecture. You might not think of ants as master builders, but their nests are incredibly complex and efficient structures. These intricate networks of tunnels and chambers provide ventilation, regulate temperature, and even have designated areas for food storage and nurseries. Talk about sustainable design. Ants have been building eco-friendly homes for millions of years. Their architectural prowess has inspired architects and engineers to rethink building design. By studying the ventilation systems in termite mounds, for example, architects have designed buildings that naturally regulate temperature, reducing the need for energy-consuming air conditioning. Ants are showing us that we can learn a lot from nature when it comes to creating sustainable and efficient structures. Section 5. Strong and flexible. Biomechanics of ant movement and soft robots. Ants are fascinating creatures, and their movement is a marvel of nature. Now let's talk about movement. Ants, despite their small size, exhibit a remarkable range of motion and strength. Ants are incredibly strong and agile for their size. They can lift objects many times their own weight, often working together to move items that seem impossible for such tiny creatures. They can lift objects many times their own weight. This strength is due to their unique muscle structure and the leverage provided by their jointed legs, and navigate through complex environments with ease. Whether it's climbing over obstacles, traversing uneven terrain, or finding their way through tight spaces, ants are masters of movement. Scientists and engineers are studying the biomechanics of ant movement. By understanding how ants achieve such feats, researchers hope to apply these principles to robotics, to design more agile and robust robots. The goal is to create machines that can mimic the flexibility and strength of ants, making them more capable in a variety of tasks. Traditional robots, with their rigid bodies and clunky movements, often struggle in environments that require flexibility and precision, can be limited in their ability to navigate tight spaces. Their rigid structures make it difficult for them to adapt to changing conditions or maneuver through confined areas, or interact with delicate objects. Handling fragile items requires a level of dexterity that traditional robots often lack. That's where soft robotics comes in. Soft robots are designed to be flexible and adaptable, much like the ants that inspire them. Inspired by the flexibility and strength of ants, engineers are developing soft robots that can squeeze through narrow gaps, manipulate fragile objects, and even adapt to changing environments. These robots are made from materials that allow them to bend, stretch, and conform to their surroundings, and even adapt to changing environments. This adaptability makes them ideal for a wide range of applications, from search and rescue missions to medical procedures. These robots have the potential to revolutionize fields like medicine, manufacturing, and even space exploration. In medicine, they could perform delicate surgeries or navigate the human body with minimal invasiveness. So next time you see an ant effortlessly carrying a crumb many times its size, take a moment to appreciate the incredible biomechanics at play. Remember the incredible biomechanics at play. The intricate movements and strength of ants are not just a marvel of nature, but a source of inspiration for cutting-edge technology. It just might inspire the next generation of robots. As we continue to learn from these tiny engineers, the future of robotics looks more flexible, adaptable, and capable than ever before. Section 6. Algorithms from the anthill: how ants are shaping AI. Here's another fascinating area where ants are making their mark: artificial intelligence, AI. Remember those pheromone trails that ants use to communicate? Well, computer scientists have been inspired by this system to develop algorithms for solving complex problems. One famous example is the ant colony optimization algorithm. It's used to find the shortest path between 2 points, just like ants finding the most efficient route to a food source. This algorithm has applications in a wide range of fields, from logistics and transportation to telecommunications and even robotics. By mimicking the way ants communicate and make decisions as a collective, we can develop more efficient and adaptable AI systems. It's amazing how these tiny creatures can inspire such groundbreaking advancements in computer science. Section 7. The future of ant-inspired innovation, a world of possibilities. As we've seen, ants are a treasure trove of inspiration for scientists and engineers. These tiny creatures, often overlooked in our daily lives, hold secrets that could revolutionize the way we approach technology and problem solving. From their incredible teamwork and swarm intelligence, which allows them to function as a single, cohesive unit, to their architectural prowess and biomechanics, ants demonstrate an efficiency and ingenuity that we are only beginning to understand. Ants are showing us a whole new way of approaching problems and designing solutions. Their ability to solve complex tasks through simple, decentralized processes is something that can be applied to many fields, and we've only just scratched the surface. The more we study these fascinating insects, the more we uncover about their sophisticated methods of communication, construction, and problem solving. As we delve deeper into the secrets of the ant world, we can expect even more groundbreaking innovations. Imagine the possibilities that lie ahead as we continue to decode the mysteries of their behavior and apply these principles to our own technology. We can expect even more groundbreaking innovations. For instance, the way ants coordinate their movements and tasks can inspire new algorithms for robotic swarms, making them more efficient and adaptable. Imagine self-healing materials inspired by ant nest construction, materials that can repair themselves when damaged, reducing waste and increasing longevity. Or even swarms of robots working together to clean up pollution, just as ants work together to maintain their habitat. These robotic swarms could also build infrastructure in hazardous environments, where it would be too dangerous for humans to operate. The possibilities are truly endless. From environmental cleanup to construction and beyond, the lessons we learn from ants can be applied in countless ways. So the next time you see an ant, take a moment to appreciate these tiny marvels of nature. They are not just insects. They are living proof that even the smallest creatures can inspire big ideas. Their ability to work together seamlessly, solve complex problems, and adapt to their environment is something that we can all learn from. They are not just insects. They are living proof that even the smallest creatures can inspire big ideas. Their intricate social structures and efficient ways of working are a testament to the power of collaboration and innovation. By learning from nature's ingenuity, we can create a more sustainable and efficient future for all. The principles that ants use to thrive in their environments can be adapted to help us solve some of the most pressing challenges we face today. By learning from nature's ingenuity, we can create a more sustainable and efficient future for all. Stay curious, my friends, and never underestimate the power of a tiny ant. We can create a more sustainable and efficient future for all. Stay curious, my friends, and never underestimate the power of a tiny ant. And remember, the next big idea might just come from the smallest of creatures. The world of possibilities is vast and waiting to be explored.